Hello and welcome to the third in the series of videos about the solution architecture framework called Spidercia, which I've written a book about, and I'm going to give an overview of the first of the topics which make up the Spidercia framework in this video. So just a bit about Spidercia. It's a solution architecture framework that I've created to provide guidance on how to follow professional solution architecture practice, and it incorporates alongside solution architecture the driving forces of solution architecture, the people, process, requirements, drilling down into elements of design, including information system engineering, which is the application part, the deployment and infrastructure, hosting the applications, testing the solution, governing the solution, so covering things like fit for purpose, risk management, etc., and automating the solution using well-established practices such as continuous integration, continuous deployment, and DevOps, and then lastly, operating the solution in life, all with a mindset and delivery approach of Agile. A bit about me. So I've been working in the IT profession for many years, and I've worked in many business domains and throughout the IT lifecycle. But I've been most at home in the solution architecture area, where I enjoy bringing things together from an end-to-end perspective and having a kind of big picture view of the overall solution and working with teams to deliver solutions. So, Spidercia. So it's been covered in previous videos. Just to elaborate, just to go revisit the topics. So we've got the solution architecture. Given that solution architecture framework is the kind of head topic, which links to the enterprise architecture, which provides the wider standards, guidance, policy, and strategy around the enterprise. The solution architecture links to other aspects of the solution. So solution architecture itself is the end-to-end view of, or views, there's multiple views usually, of the solution, but it links to via these threads, which are part of the Spidercia framework, it links to the other topics. So we're going to cover this topic in this video. The next video will cover people, process, and requirements. There'll be a single video combining integrated system engineering or design and deployment infrastructure design together. And then the 4 topics are the last video. So moving on. So solution architecture, the first part of it is really the engagement and collaboration with a number of stakeholders. So we need to identify who all these people are that are going to be involved in the solution. More in stakeholder management in the next video when we talk about people, process, and requirements. But the key thing is solution architecture, when you're starting on your solution, is understanding these key elements. So what are your business goals? What are you trying to achieve with this solution? What enterprise architecture are you working within? What's your framework? So what are there existing architectures that you need to align with at high enterprise level? Are there associated standards and policies you need to adhere to? What are your constraints in terms of costs, budgets, timelines, resources, skills? Quite a lot of things to contend with there that will drive a lot of your decision making. What solutions are there that you will integrate with or will influence your solutions? So likely your solution will involve some element of system integration, be it automated or manual, preferably automated. So what are other solutions you'll have to work with, and importantly, what are the boundaries that you throw around your solution in terms of scope? And what's the business process, as in the current business process? Part of your solution may well be, and probably will be, involving some element of to-be business process, as in the new business process. But you need to understand what the as is there. So this engagement should result in a summary of what you're trying to achieve, the very high level requirements, the big picture of what you think the solution is going to look like, and some sort of element of planning in terms of how you're going to deliver it. So is it going to be via Scrum or what kind of delivery approach will you take with the various options of Agile, etc. You don't necessarily have to decide at this point what specific Agile method you're going to use, but it's more kind of the general approach. And importantly, kind of what milestone you need to have some view of what you're trying to achieve when you're trying to achieve it. And again, near the start of the solution, it's really important to bear in mind a lot of what you're dealing with as a solution architect is knowledge, information about a solution. And this little diagram is quite a useful way of showing that there's different types of knowledge. So there's things we're pretty sure about, things we are aware of and understand. There's things that we have knowledge of, but we don't fully understand. So maybe things like new technology, etc. There's things we understand we're not aware of. So there's things we need to find out. We need to do some investigations, that sort of thing. And probably the most important part, but also the scariest part, is there's things we don't know we don't know. So this is where I always say a lot of doing solution architect is being kind of a detective. You've got to work out, got to research, got to work out areas that you just don't know and areas you don't know. So it's a lot of information gathering, especially at the start of the solution architecture process. I won't go into detail about each of these, but the book covers the more detail in terms of decision-making techniques, all sorts of different options, and a lot of what you do as a solution architect is making decisions and, importantly, justifying those decisions. You're going to deal with a lot of stakeholders, and in my view, you need to be able to justify what you're doing, partly because what you're doing will have important implications on the delivery, the costs, and other aspects of the solution. And also it's important to get buy-in to decisions that you're making. As I say, I won't go into these in any detail, but more detail in the book around each of these techniques. And it's also important to have a view of what I often talk about in the book, an optimal solution architecture. And you can use other terms to describe this. So this is things like a quality solution architecture, but basically it's something to define that you've met what you wanted to achieve with a solution. So in the book, again, I go in this more detail, but there's some suggestions on what I would classify as an optimal solution architecture. It includes having a clear scope, addressing cost constraints, appropriate documentation, and we covered in the previous video, too little, too much documentation, and in my view of a good solid artifact structure depending on the complexity of a solution. You need to address requirements, stakeholders, importantly, both functional and non-functional requirements. There's a whole bunch of concerns you need to address. You need to look at automation. That's the modern world. You should automate as much as feasible, but not necessarily over-automate. But I cover these in a bit more detail in the book, but really important to have a view yourself of what you would aim for in terms of an optimal solution architecture. And it's also important, reuse is really important. You need There's no point reinventing the wheel, and it's a cliche, it's a well-worn term, but it is absolutely true. There are lots of very bright people that produce lots of very useful principles, maybe within your enterprise, it may be within external bodies like the Open Group, the cloud of very good, well-architected frameworks you can use, and vendors, lean heavily on your vendors for guidelines as well. So lots of reuse that you can feed in to your solution architecture. So now we get on to the core of the solution architecture in terms of actually a deliverable. And it's what I call the solution architecture document. There's many other people use that term, but may use other terms like solution design or solution specification. But solution architecture document is a fairly commonly used term. And this diagram outlines the structure, in my view, a good solid structure to a solution architecture document or SAD. So inputs into the SAD include the enterprise architecture and specific requirements, hopefully in the form of a backlog for this solution, helped formalized by stakeholders. Also inputs include other solutions, so we've got a clear boundary with our solutions between other solutions. And the structure is fairly clear. So you're scoping your solution, you're outlining your requirements, you're justifying your key decisions, your architecturally significant decisions that are going to shape the solution. And probably the key part is the solution views. I'll go into this in a bit more detail later. The solution views are the overall views which define the solutions. So they may include the applications, the data, the infrastructure, the business, the service, and these provide usually models around your overall solution. I say I'll go into this in a bit more detail later slides. So the roadmap is more about the evolution of the solution, so where you're going to be 3, 6 months, 1 year, whatever down the line. So this is your horizon view of the solution. The CRADE, so this is the constraints, risks, assumptions, issues, and dependencies, which will provide certain constraints and other things you need to be aware of around the solution that can help define the solution. So there's a whole number of things to contend with there. A traceability matrix is tracing back to your requirements. How do you know the solution meets your original requirements? And versioning is important, so you've got a controlled approach to your solution architecture. So it's version, so you know at what version produces what parts of the solution. Okay, let's move on. So I mentioned there about architecturally significant decisions. I've got there's different views of architecturally significant, but in my view, it's a really judgment of what an ASD is. But there's something really important that's going to drive the shape of the solution. So it could be technology choices, decisions that really impact your costs or your resource usage, or which impact how you address requirements, in particular non-functional requirements. And really importantly, it can be exceptions to your wider enterprise strategy. So things that, for whatever reason, doesn't align with your enterprise. So that can be okay, but as long as you justify it. And there are very often good reasons that you won't fit into the overall enterprise architecture in some ways, as long as that's justified within the context of this solution. And this outlines how we record individual ASDs. So a bit about views or concerns, viewpoints, and views. So this is from TOGAF. It's a very, very important and very useful part of TOGAF. And I like to use it for solution architecture. So TOGAF is enterprise architecture in the main, and I like to reuse aspects of it for solution architecture, and the views is probably the key aspect I think is really, really useful. So taking it from left to right here, you've got concerns, which are from your stakeholders, effectively interests. What are you interested in as a stakeholder for a particular solution? So if you take some examples, operations stakeholders, where they're interested in how they're going to run the solution. Business stakeholders, they're interested in probably how much it's going to cost and how long it's going to take and what functionality it's going to provide. security stakeholders, well, they're interested in how it meets your security regulations. So the viewpoint is a generic specification. So it's kind of it's a mental model. It's a generic view of how you'd meet concerns, and then the view itself is specific for this solution. So it's a specific viewpoint to address certain concerns for stakeholders. So that's what viewpoints, concerns, viewpoints, and views are. And in the book, I cover a series of solution architecture views. Now, these aren't by no means complete. These are kind of a starter, if you like, for a solution architecture, kind of generic views that you can reuse. And they're views that I've used commonly within my time as a solution architect. So there's the overall end-to-end summary views. There's a view addresses business process, information views, application views. You get the idea, and it's each of these views has different models. So I go into I'll go into a bit more detail here, but there's much more detail in the book around suggested notation for views. So different views may have different model types, because different models lend themselves to different aspects of the solution. The views outline what concerns they're addressing and what stakeholders they're really aimed at, and perhaps what other views they link to. So the views aren't in isolation; they kind of relate to other views as well. And as you create these views, you will be starting effectively to paint a picture of your solution, how your solution meets your requirements and how it communicates how it meets your requirements. So now I'm going to go into a bit more detail about modeling. So the models are really around how you build views. So you can see how this is coming together. You've got your concerns that you want to address, and your views are addressing those concerns, and we use models. Primarily, views are made up of models. It's really the most efficient and effective way to communicate your architecture. So there's a bit about principles of modeling. So these are some of my opinions on how to model effectively. Models shouldn't be done in isolation. Again, I've said this many times. You shouldn't be architecting in isolation. So models are really good for getting everyone to participate, and everyone should be involved in participation and ownership of models. You need to choose the right models for the right view. So different notation for different models, for different views is really important. Make sure the models are testable. Don't do one model in serial after another. You can model in parallel, makes it more interesting and also much more efficient. Make sure the models are simple and easy to communicate, and you do it gradually, do it in increments. Don't boil the ocean. Do it sprint like as I covered in the previous video. Building these solutions gradually in digestible chunks rather than doing it as a one-off. We're not doing big design up front here. So a bit more detail again in the book. I know I keep saying that, but we're just here to summarize the book. But these are the principles of modeling I like to apply. So now the next few slides are going to go through the modeling types. Now I'm not going to cover all models types. There's many hundreds of types, but I'm going to go through, my view, some of the big most used model types. Starting with one that's not really a model, rich picture. It's rich picture is really the overall summary view, and it's not really using any modeling notation. It can be whatever you want, whatever you think will communicate best your solution to the majority of stakeholders. So it's really for you to come up with your own kind of pseudo notation, something you think within the context of your enterprise best communicates that. But the important thing with this a rich picture is it is the big picture view. It's the overall view, and keep it consistent. Keep it. I've got big pictures that I will drag up from solutions to show people hundreds of times, literally. But in order to do that, I need consistency. So people can often recognize my diagrams from afar because they are consistent. Right, so now we're going to get into more specific modeling notation types. Archimate is a well-known notation type used within enterprise architecture through TOGAF. You don't have to use TOGAF to use Archimate, but quite often go hand in hand. But it is widely used in enterprise architecture, but also solution architecture as well. And it is popular because it does combine end-to-end architectures, be the enterprise level or solution level, because it combines, and we can see here, it combines different parts of a solution. This is technology, this is application, this is business. So that's what Archimate is really good at, providing the different aspects of a solution, the different views of a solution using a common, consistent notation. So in the views that I've outlined in the book, I use this. I recommend this quite widely. I've also got quite a few worked examples using ECS Health, fictitious company, and the telehealth fictitious solution, which use Archimate and show different views through this notation. It's owned by the Open Group. At the time of writing, it's 3.2, probably moved on very quickly. And there's various tools you can use. It's built into many enterprise tools, very powerful. You can even develop auto-generate specifications from it, and it's evolving all the time. I'm not going to go through the details of it. There's many good books on Archimate. I think I've linked a couple from my own book. But yeah, there's certainly something as a solution architect I think you should be aware of, and if not use on a regular basis, certainly start thinking about using it in some aspects of your solution architecture. C4 modeling is really interesting. It's not technically a notation, but it's more of a structure of solution architecture. C4 means it's 4 levels to it. So it goes from the very high level view down to the component view that you can build from. So it's a pretty simple approach. Doesn't incorporate things like process modeling, but from a static solution point of view, it's a really useful way of visualizing your different levels of your solution. The C4 website has a really good worked example of it's an internet banking system, and drilling down from the big picture down to individual components which make up the banking system and the people involved. So, as I say, it doesn't really incorporate business process, but it doesn't outline the different components that make up solution interactions between those solutions. So it's really, really useful and something I use quite regularly. UML modeling. So this is well known probably by most designers. It's one of those notations, very wide. You can see here a number of different types of diagrams, so you can kind of cherry pick what you want to use. Some of the more commonly used diagrams from structural or the class diagrams or component diagrams, from behavioral, which is more dynamic aspects of the solution. Use case and sequence diagrams are used. So I cover in the book a bit more in terms of where I would use UML. It kind of come in and out of favour over the years. It's maybe a little bit out because it's kind of seen as maybe a bit technical, a bit difficult for non-technical stakeholders to understand. I think it's one of those, as I say, you kind of pick what you think are useful. I use sequence diagrams a lot, and I think it's really good for showing dynamic interaction flows within and between components. I don't think it's great for overall big picture architecture. I think it's a bit overly unwieldy for that, but as I say, I think there's really useful aspects of it you can use. there's some examples here again. Sequence diagram. I make a lot of use of this. I think it's a really good way of showing the flows between the different components at the top, and these are the different interactions. Cloud providers, yeah, the main hyperscaler clouds have done a really good job, I think, of providing icons and modeling approaches to using their cloud. So there's even some tools you can use to even auto-generate deployments in the cloud. So I think it's given the constant move of solutions to the cloud, it's really important to appreciate the different cloud provider icons. I wouldn't really call them modeling languages because they're not generic enough. They're specific to each cloud, but yeah, I think it's important for communication more than anything, because people really understand these icons. They are quite visual, they're quite understandable, and most solution architects will deal with the cloud. Even if you're not a cloud architect, you will probably have some dealings with cloud solutions, and it's important to understand these icons that the public cloud providers provide. So again, I detail a bit more in the book around that. This one's an example from AWS, and quite really good at visualizing cloud solutions. BPM modeling, really useful to anything to do with business process. I highly recommend it. It covers everything you can think of around how you would detail processes from the high level down to the detailed level. So it contains, well, you can group into 4 different element types. I won't go into any detail about it, but it's really there for processes, be it doesn't have to be business process, it can be down to very detailed operational process. Very widely used in terms of tool support, and like a lot of things, a bit of a theme in the book is consistency. So if you're going to adopt notation, adopt it in a consistent way, and anything to do with business process, I would strongly recommend using BPMN. We get down to the data level, data structures. You can't really beat ERD, so it's entity relationship diagrams. So this is from database technologies, and this, yeah, things move on. So RDBMS maybe not so much the flavor these days, more object databases, etc. But you still need to understand your data. You still need to model your data, be it in tabular format or document format or whatever the structure is. So you need to, as a solution architect, model the data in terms of the structure and also the dynamic nature. So the DFDs cover this. There's lots of different modeling techniques. It's something that's moving quite quickly. Industry, as I say, has different types of storing your data, much more choice than there used to be. But you've got the kind of 2 elements of it: your data structures and your more dynamic flows around your data. So in this table, I kind of summarize my view of what notations to use for what views. So it's not a case of I wouldn't adopt one notation throughout a solution architecture. I don't think data modeling is quite, I don't think there's one size fits all. I don't think there's a notation which will fit all views just because of the nature of the views and the nature of the notations. So this summarizes the notations I would suggest using for different views. Again, it's very much preference, organizational preference, or personal preference, whatever. It's important to appreciate that you've got to have a good think about how to communicate, how to analyze your different views with the appropriate modeling notation. I won't go through this in detail, and as I say, bit more detail in the book, but this is my views of what notation to use. But on design patterns now, so and you can kind of link design patterns to models. Design patterns are always communicated as models, not always, but more and more commonly. But from a solution architecture perspective, really important to adopt a mindset of reuse, and design patterns help with reuse. So design patterns can come in many different flavors, many different sources. So you can have external design patterns. TOGAF again has very useful design patterns. In the cloud, there's no shortage of design patterns in the cloud. Some examples here. And you can have general design patterns, especially around applications. Lots and lots of different design patterns to use. The important thing is to have an approach to design patterns. And probably when you're starting a solution architecture, make sure it's one of the first things you think about is reuse and reusing existing thinking around solutions. There will be parts of your solution which may be well unique, but probably the vast majority of your solution will not be unique and will have been thought of and issues encountered and best practice specified. So it would be an intelligent thing to do, to take all that existing information on board when you're doing a solution. So design patterns are means of collating and feeding into your solution that existing work has been done on already by others. So a bit of risks and technical debt, which is a specific type of risk. So as part of a solution architect role, you need to be aware that there will be risks of your solution. So the risks would be your solution may fail to meet requirements, or your solution may go over budget, or your solution may be difficult to operate. You need to quantify or at least elaborate on risks as part of a solution architect. Every solution has risks. A solution without risks, I don't think would be useful. You've got to have risks wherever you go as a solution architect. So it's important to appreciate and elaborate and communicate those risks, and outline in the book a bit more about technical debt, because it's a really important aspect of risk that, given the constraints you have to deal with as a solution architect, you will have to cut corners to a certain extent. So you'll have to do things tactically, and it's important to make sure that tactical doesn't become the strategic. So, because that's a risk in itself. That's the more and more tactical solutions you put in place, the more you're facing risk of something breaking or the solution becoming unmaintainable. So it's important to elaborate on what that technical debt is, so you can plan in remediating it. So it isn't. We've all been there. We'll have to cut corners to a certain extent. We'll have to do things maybe quicker than we wanted and put in tactical solutions. We would prefer to put in a strategic solution, but we have to be practical as well. But as long as you're aware of that technical debt, as long as you plan to remediate it, then that can be okay. Other aspects of what I call the CRADE in the solution architecture assumptions. So we just need to elaborate and document assumptions that we've made that have influence on the solution. Same issues are things we have to deal with. So this is different from a risk, which things we may have to deal with, we don't entirely know. But risks are things here and now we have to deal with, which could be blockers to the solution. So again, we need to lay those out in the solution architecture. And dependencies are things that aren't necessarily part of the solution, but they're aspects we're dependent on. Could be other solutions which we need to feed into our solution. Okay, so roadmaps. So if we create our solution architecture document. We might plan out alongside our sprint methodology the implementation of the solution, but we also have to have what I call a horizon view of the solution, effectively a roadmap, and it's important to appreciate that the further you get out, the more you just don't know, and that's fine, that's okay. But as long as you have a solution architecture, should have a vision. I often think solution architecture as a product owner as well, and again I talk about that a little bit in the book about how Scrum methodology has a product owner, and I would equate the product owner with a solution architect, and I'd expect a product owner to know for the duration of the solution where it's headed, how it's going to evolve over the weeks, months, and years. And you go into as you get further out, you're going to have much more. It's going to be more vague, but as long as you have a big picture that you can work to, that's okay. And you can see here the different types of plans. So the daily plan is going to be very detailed. We're going to know pretty much precisely what we're going to be doing. Iteration plans, that might be more like a sprint. So we have a good idea what we're going to do, maybe just not on a very, very specific task basis. And you can see here we're getting out into a bit more vagueness in terms of the detail and the forecasts. As a solution architect, you will deal with cost a lot, because at the end of the day we're working in businesses and we have budgets to work within, so you need to appreciate the different cost types, and you may be entrusted with the budget, or you may be working with a program or project manager who has the budget, but either way you need to understand what makes up the costs of your solution. So a bit of a summary here. So you've got two broad cost types: your CapEx, your capital expenditure, and your OpEx, your operational expenditure, and the different elements which those comprise of. Yeah, as you need to have a good bit of accountant's hat on, but really important that you understand to implement in your solution architecture what's going to cost and what are the different elements of those costs. And there's a little bit of estimation here as well. So you might not know the costs. In fact, it's a good part of your cost you will not know, so you have to do an element of estimation as well. So there's different approaches to cost estimation, which I've summarized here, but details are in the book. Cost optimization is also important, and it's important everywhere, but probably specifically important in the cloud, because using clouds can be expensive, especially if you don't use them effectively from a cost perspective. There's lots of techniques around cost optimization. Some of them are summarized here. It's really important, solution architect, that you do have a cost optimization hat on, and you do think about your solution in those terms. So make some examples, include the reservation here, for example. So if you're building infrastructure on the cloud, if it's going to be long term, you probably want to reserve infrastructure as opposed to pay as you go, because the reserving is much, much cheaper. Automation, you need to build in automation from the start, and that will reduce your labour costs, because you have much less manual effort to do if much of your operations are automated. So it's something to consider, and it's an important part of your solution architecture. Yeah, communicating the architecture. So I've mentioned this in the roles part of the previous video. Really important that you have a strategy around communication. As I say, no point producing a solution architecture if you don't communicate it. You're not working in isolation here. You're working with stakeholders, be them feeding in to your solution or taking your solution and helping implement it. So you really need to communicate this and have a strategy for communicating what you're doing and working with others and getting feedbacks. And I've covered models a lot in previous slides. Really, really important. If you're having a conversation about a solution and you're not using some sort of model, I think a conversation is going to be hard because people will paint their own pictures in their heads and they're probably going to be different. So having those models and visuals to communicate solutions as part of your communication strategy is really, really important. Prototyping, yeah, really useful. And probably most solutions you will come across prototyping because most solutions have their specifics that you might not understand. So it might be new technology, it might be just the application of that technology, or specific environments, or it might be new people involved. But it's useful to have the early stages of implementing a solution architecture is prototyping that early on. And it depends on the people involved. I'm quite hands-on myself and I quite like to get involved. Some solution architectures maybe hands-off, but it's really important to be part of the development team from the start, and engaging in prototyping is really useful from that perspective. Okay, so as you can gather, there's lots of elements to a solution architecture, and not surprisingly, there's lots of tools you can use in creating and delivering a solution architecture. Got a big table in the book around suggested tools. I mean, these are just my suggestions based on experience I've got. This is kind of the summary of the different tool types. I'm not here outlining any particular tools, that's in the book, but for each of these I've got some suggested tools which I recommend. And it's important to think up front about what tools yourself and your team and people involved in a wider delivery are comfortable with. Some tools are better than others, some tools are cheaper than others. You've got to have a think, and again, consistency is important. It's not good if everyone's using different tools, so you've got to have a think up front about what tools are best for your job in this particular solution. A bit about pitfalls. Yeah, it's lots of things that can go wrong in a solution architecture, and it's important to realize experience does help here, and I've made quite a big thing about reuse and best practice in previous slides, and it's important to realize that it takes a lot of experience to understand what can go right, but hopefully what can go wrong. So I've outlined some pitfalls here. I won't go into much detail because, again, there's more in the book, as you suspect I might say. But it's probably I'll pick out some key ones here. So yeah, sometimes you have to sell the need for a solution architecture, but that's just the way it is. Some people just want to get down to coding or do whatever to get to the more tangible parts of the solution, but sometimes you need to sell the need for solution architecture, and perhaps frameworks like spidercia can help with this, to showing the benefits of having a framework and having a solution architecture. Sometimes you can go in solution architecture without really doing your upfront knowledge gathering, so really understanding the problem, and equally not engaging with stakeholders. So you're going to be creating a solution that meet all the business needs. You're not going to decompose your architecture, so it's going to either be maintained too high level, or it's going to be complete and it's not going to have sufficient views. I won't go through all these in detail, again, a bit more in the book, but you can see here there's lots of pitfalls you can avoid if you step back and reuse whatever frameworks and best practice and design patterns that are available. Can't emphasize the importance of reuse enough, because most people have done solution architecture have fallen into many of these pitfalls, and the experience is really, really important. So hopefully that gives a bit of an overview of the solution architecture topic. It's the first in a series of topics which make up the spidercia framework, I'm going to, in the next video, I'm going to go into the details of what I call people process requirements, which are driving the solution architecture. Some people might think, well, why is that not first? Because that's what's driving solution architecture. Well, I could do them together. They're just the two big topics in their own right. And given this is a solution architecture framework, I've done solution architecture first. But the next one's going to go into more requirements, stakeholder engagement, business process, that sort of thing. But hopefully that's useful. As I say, much more detail around this in the book. And here is the link to the book. Here are my details. And I'm absolutely delighted to hear from anyone who wants to ask questions, collaborate, and look forward to hearing from you. So I shall say goodbye and see you in the next video. Thank you. Goodbye.